All right, so we're at chapter 4, uh, applications of linear equations in two variables or systems of equations. 4.4 is talking about applications, and we're talking about principal and interest now, example 1. So let's go through example 1. We'll see what happens with example 1. We've gone through a couple of examples of mixtures, but here's the principal and interest start. So here's kind of the idea about principal and interest. Here's the formula right there. Interest equals principal times rate times time. Interest equals principal times rate, or R, times time. And this is something that you should probably remember, probably memorize. Interest equals principal times rate times time. I is the interest. So interest is the amount that you pay the bank for borrowing money. In other words, if you've got a loan, you go to the bank, you say, I'd like to borrow some money to go to college. Interest is the amount of money that you pay the bank, basically, for borrowing the money. So that's the interest that you calculate. P is the principal that you start with. P is principal, and that's the amount that you start with, either from a loan, the amount that they give you, that's the principal, or the amount of money that you take to them and say, I'd like to invest this. That's the starting amount is the principal. R is the annual interest rate as a decimal. In other words, if here's our rate, if you say, well, my rate is 5%, well, the rate is 5%, but that would be 5 per 100, because that's what 5% means. And what does that mean? And as far as a decimal, as far as a number goes, 0.05. So that would be the R, 0.05. If you're given a rate of 5%, the R has to be 0.05 because we're going to use it in the formula. And T is the amount of time in years. All right, so that said, interest equals principal times rate times time. Here's our definitions as well. Let's go through an idea about what information we've got here. Joanne has a total of $6,000 to deposit in two accounts. One account earns 3.5% interest. The other earns 2.5% interest. If the total amount of interest at the end of 1 year is $195, find the amount she deposited in each account. All right, well, what we have to do is we've got to set up another system of equations, and we have to start with the two different accounts as columns, the two different accounts that she has, 3.5% and 2.5%, and a total. So we're going to start with that as columns. We're going to set up our table somewhat, and we're going to say, you know what, something goes in each row. So they're talking about two different things. Number one is dollar amount, and number two is an interest. So you can talk about, I guess both would be dollar amounts. So one would be principal, one would be interest. So let's talk about one as principal. And the principal that goes into a 3.5% account, well, we're going to have to define that because they're asking to find the amount she deposited in each account, the 3.5% and the 2.5%. So we'd have to define X as amount of principal in 3.5%. Y is the amount in the 2.5%. So we can go down here and say, well, the amount of principal in the 3.5%, that's X. Amount of in the 2.5%, that's Y. And she said that the problem says she's got a total of $6,000 to deposit in two accounts. That would be the total principal that she has in her pockets to go and deposit into two accounts. So that would be a total of $6,000. The interest that she gets, oops, I'm going to change colors here. The interest that she gets can be thought of as the next set of equations, or I guess the next equation. Let's see, the total amount of interest at the end of 1 year is $195. Total is $195. How much interest does she get from this account? Well, it's 1 year, so interest would be equal to principal times rate times time. Time is 1 year. Rate is 3.5, or in terms of the R, the rate is 3.5, so the R is 0.035. So I'm going to start this as 0.035. 0.035 times the principal, which would be x, times the time. Time is 1 year, so we don't really have to put that down here, but that's essentially what we've got. Principal, x. Rate, or r, I guess. Rate is 3.5, so that means r is 0.035, times time is 1 year, so that kind of goes away because it's just 1 times both of these, and that's the interest that we've got here. And the same can be held true here for interest here. This would be 0.025, because that's our r, times y principal times 1. And you could actually put this as principal is x, x times 0.035 times 1. But to make it a little clearer and a little more, I suppose, standard in terms of algebra, the coefficient usually comes first. So that's why I put the 0.035 times x here and the 0.025 times y here. But essentially, I got it from P interest equals principal times rate times time, or P times R times T. So now we've got a system of equations that x dollars in the 3.5% account plus y dollars in the 2.5% account equals 6,000. And in the red, we've got 0.035x plus 0.025y equals $195, or in terms of our system, 195. And now, I guess what I would do here is I would say, let's see if I can extend the page. I sure can. All right, to make it clearer, I would say, you know what? I would multiply this by 1, 2, 3 by 1,000. Multiply that by 1,000, and multiply this by 1,000, just to make it a little clearer. So I'm going to multiply the red by 1,000. And that will give me, let's see, I hate to do this, but I'm going to go down here. And I'm going to say multiply this by 1,000, moves the decimal point 3 spots. So this would give me 35x plus, multiply this by 1,000. Just to, in other words, to clear out the decimals. Multiply this by 1,000, moves the decimal point 3 spots, plus 25y equals 195 times 1,000, 195, 0, 0, 0. And I've still got my green equation, x plus y equals measly 6,000 over here. And now I've got a system of equations. Let's see, what would I do? You could use a substitution method, or you could simply use multiplication method, or sorry, the addition method, to multiply the green equation by probably a negative either 25 or 35. And I would say I would multiply by Alright, multiply by, that was kind of funny, negative 25. So that would give me negative 25x minus 25y equals 6,000 times 25. Negative 25 is 150,000, I do believe. Yes. And I would just bring down the red equation. Say here's my 35x plus 25y equals 195, 0, 0, 0. And we're starting to get into some bigger numbers, but that's really not a big issue because we can use calculators here. Add up this, negative 25 plus 35 gives me a positive 10x equals 150 plus 195. Oh, sorry, you know what? I'm going to change this because that should be a negative, because I forgot to multiply by the negative. We took this green equation, multiplied by negative 25, so it should be negative 25x minus 25y equals a negative 150,000. And now, when we add things up, that adds up to 10x, this adds up to 0, this adds up to 45,000. So when we divide by 10, x then equals 4,500. So now x equals 4,500. If x equals 4,500, well then y equals, by this equation, y equals 1,500. And then we've got our answer. answers. But the trick is, and I would go back and double check definitely into both of these. This green equation seems to work pretty well. 1500 plus 4500 is 6000. I would double check the red equation just to make sure. Let's see. And the trick then is to set up the investments in terms of your columns. 3.5% column here, 2.5% column here, and a total column here. And then one is principal, one row is principal, one row is interest, and the principal and interest gives you your system of equations. And then after this, you just solve it. And for this one, I multiplied by 1,000 to clear out the decimals because it seems to make it a little easier. But that's essentially what a principal and interest question looks like.